Using the player. Toggle the menu button to see where you are in the training and to jump to any specific section. Toggle the Notes button to see the notes for each slide. Use the magnifying glass to search for specific text within the unit. Toggle the hamburger to display slides full screen and to reveal or hide the menu and notes. The Resources button in the top left contains helpful links to documentation and websites. Control the player volume at the bottom of your screen next to the Play button. Continuing along the bottom of your screen, you can also reload a slide and move to previous and next slides using the buttons in the lower right-hand corner.
This is an extensive, challenging course that presents essential concepts you need to learn about Magento 2 over a series of comprehensive units. It assumes you have prior experience with Magento 1 and highlights changes in features and functionality between the two product versions throughout the course. Be sure to give yourself enough time to go through the material at your own pace. This course is appropriate for developers who are experienced working with and extending the Magento platform. The depth of the content may prove challenging to new developers who have little or no familiarity with Magento. Magento 2 is a robust, flexible, and complex product, and it requires many hours of dedicated practice to become proficient in its use. This course is one important piece, but not the only required piece, in helping you to develop your expertise using the Magento 2 platform. You will also need to work extensively with the product to build your skills. Studies have shown that the more senses you use to learn a subject, the better your comprehension and retention of the material. So do not use just the slides or the notes to learn the material. Be sure to both listen to and read the slides as a topic is explained, and use the course guide notes. The course guide presents the narration, audio, in written form, while the slide highlights key concepts. Find the most effective way to use both to match your learning style. For example, you may want to read the slide first for a general grasp of the topic, then play the audio as you follow along with the full notes to fill in all the details. Remember, you can replay each slide as many times as needed to comprehend the material. Be sure to do all the exercises presented in the course, as these are key learning opportunities and provide practical, hands-on experience with a native Magento 2 installation. These exercises have been specifically designed to help solidify the concepts when presented. This is also why you should complete the exercises when they appear in the course and not skip them to be completed at another time. Take the time to just explore the code, looking for examples of the topics presented. Everyone learns differently, but following this advice should help you get the most out of your course.
Fundamentals of Magento Development, Unit 1.
In this module, we will discuss the preparation steps you should take to set up your Magento 2 installation for development. We will cover configuration aspects in the next module. In particular, this module will discuss environment setup and introduce the system modes available for different phases of the development lifecycle. Magento 2 requires the familiar LAMP stack, Linux, Apache, MySQL, and PHP, along with PHP Composer, a tool for managing external dependencies. Magento makes extensive use of Composer for downloading and installing external dependencies such as Symfony. For installation, you need a cloning repository. Using Composer is recommended. See the installation guide for more information.
Hello! In this video, we will see how to install Magento 2.3. First of all, we have to verify that Magento technology stack requirements are met. You can see the list of Magento technology stack requirements on the official documentation website that you can see here on the screen. You need to have your web server properly configured it could be Apache or Nginx. You need to have a database of a certain version, PHP, and a list of required PHP extensions. Assuming that all requirements are met, we will proceed to getting the Magento software. There are 3 different ways how we can install Magento. We can download a package, we can clone repository, or we can get Composer meta package. And there are 2 different Magento editions, Magento Open Source and Magento Commerce. We will install Magento Open Source. And we will use Composer meta package approach, since it's the most popular one. Before you can receive a meta package, you have to make sure that you have access to repo magento.com. This access is free, and you can find instructions how you can obtain access key to repo magento.com on this website as well. Now we will clone the command here. We will copy the command and we will paste it and run. You may need to wait a while. It very much depends on the system, so it may take a while to download all required packages. Okay, we have our packages downloaded. Next step would be to download sample data modules. We need sample data. We will use it in our training, in our demo videos, because it provides a set of modules which would fill some data into our project. So we will have some products, some categories, and in general it's very helpful, especially for learning purposes. So we will use Magento command line in order to install those packages. So we need install optional sample data modules, and we will do it using Composer. There is a command command bin Magento sample data deploy that we will use. We will execute PHP and then the command bin Magento sample data deploy. This command will download sample data modules. It will not install them yet, but download. And again, we may need to wait a while. Now we have to enter our credentials that we have for Magento repository. So you should have your credentials obtained. I will copy mine and password. Now we see that our modules being downloaded. And again, we have to wait a little bit until modules will be downloaded. Okay, after we install our sample data, we may proceed now with installation of Magento. We configured virtual host in Nginx, and we omit this step here. You can find instructions how to do that in the documentations, in the Magento documentation. In a few words, you should copy a snippet of configuration file from the documentation. It's a very simple one, and all it does, you have to specify your URL, your document root, and you have to include a file which comes together with Magento package. This is enough to configure Magento for Nginx. For Apache, configuration may be different. You will need just to configure virtual host. Now when you have it done, we can take a look into that nginx config sample file, which would be included in our nginx configuration. We may proceed to Magento installation itself. So in order to do that, we'll go to our browser, we hit our URL, trainingmagentou.com, and we would see this page. On this page, we would say agree and set up Magento, and we will start our readiness check. So check passed, and we can proceed. So we will install our database. So we'll use IP here. Our server name would be www, and database name would be Magento U. So you can specify your credentials to connect to the database. Then click Next. This would be our URL, and we also need to specify admin URL. We will use just admin. Then we would specify our time zone. We would use GMT time zone standard, and we will use all the standard configuration here and proceed. Now we need to create an admin account. So we would say admin magento.com, whatever, enter password, and we're good to go. Now we can proceed with installation by clicking Install Now. Now we have to wait until installation is completed. So when installation process is over, we would see this success screen. Now we can go to the storefront, or we can go to the admin panel, and this means that installation of our Magento 2.3 is completed. Let's wait a little bit to see our storefront. This is Luma theme. It's installed with the sample data that we did. So all these products, banners, it's all sample data. Here we have admin panel where we can log in. Takes a while first load because Magento will generate all the cache and all the static resources, so it takes a while. And here we have our admin panel. It's still loading. You can see it's Magento 2.3.1, the latest version at this moment, but installation process should be the same on any version, higher version or lower version. So now we see different products, different category pages, and actually we have our Magento installed.
The topics to be addressed in this module are an overview of the Magento 2 platform, an overview of its architecture, and a discussion around modules and their role in Magento 2's system. Magento 2 continues to provide the same flexibility and extensibility of Magento 1 while introducing structural changes that address challenges around describing dependencies across the system for easier upgrades and around containing business logic within one system layer. Magento 2's instantiation mechanism and code generation provide numerous ways to customize, such as through the use of plugins. Magento 2, like Magento 1, is a modular system but to a much higher degree. Magento 2 assigns greater independence to the modules. They function more as standalone units. An area is a scope in the configuration that allows you to load only the configuration files and options that are required for a specific request. Within Magento 2, there are areas for front-end, admin, and install. The purpose of areas within Magento is to increase efficiency by not requiring the loading of the entire configuration for every request. For example, if you are invoking a REST web service, a corresponding area, such as /rest, loads code that answers only the REST call, and it does not load, for example, the code that generates HTML pages using layouts. Each area can have completely different code on how to process URLs and requests. Typically, an area contains behavior and view components that operate separately. However, an area can have only one component, for instance, the cron area, which has no view component. If your extension works in several areas, you should make sure it has separate behavior and view components for each area. This slide lists key Magento 2 concepts. We'll review them one by one. Number 1. Magento 2 is a modular system with its own specific structure. There are some exceptions to this rule. For example, framework files are not technically modular, and some generic static files belong to a theme, not a module. Most of the Magento 2 code is wrapped in modules. We will cover module folder structure later. Number 2. Themes are a set of files that define how a website will look. Themes include all types of static assets and are deeply connected to the Magento 2 rendering system, which is covered in Unit 3. Some static files are located in the module folder, while others are in a theme location. Themes and modules are connected, a concept covered in more detail later. For now, it is important to understand that while PHP code is most likely located in modules, generic static assets are organized in themes. Number 3. Layout, an essential concept in the Magento 2 rendering system, is a set of XML files that define which elements should be on a page, topology. Layout configuration defines which blocks should be present on a page and the block hierarchy. Block is a special PHP class in Magento 2 that is usually, but not always, connected to a template. Each block's generated HTML together comprises the whole page. So a block class generates a piece of HTML using its template, and layout defines which blocks should be included on the page. Layouts are highly configurable and extendable. You can create layout updates in your module to modify any existing page, or create a new layout for a new page. We will discuss layouts in depth in Unit 3. Number 4. In Magento 2, there are several types of configuration files. For example, events.xml, routes.xml, acl.xml, and more. Those files are distributed across different modules. In other words, each module can have its own set of standard config files. When a certain type of information is requested by an application, like a list of available routes, Magento merges all config files of a certain type, for example routes.xml, and derives information from there. Number 5. Object instantiation magic, or dependency injection, DI, is a Magento 2 feature. When you need a new object, you declare it or its interface in the constructor, and Magento will deliver an instance. We will discuss this in greater depth later in this unit in Module 5. Number 6. Naming conventions are another important feature of Magento. Routes are constructed in a special way in Magento 2. To process a route, you need to create a corresponding controller and register your route in routes.xml. We will talk more about this in the next unit, Unit 2. Layouts are also connected to route names. So in order to add a new element to a page, you need to create a special layout update file, whose name is related to the route. We will talk about layouts in Unit 3. Number 7. Events and plugins are two major customization techniques in Magento 2. Events are fired in the core code, and developers can add observers to that event. Each event has parameters, so a developer can use or even modify them. Plugin technology allows developers to add specific behavior to every public method of each class. This is a very powerful tool, described more fully later in this unit in Module 7.
This slide lists major Magento 2 components. These are high-level elements of Magento with which every developer will interact. Configuration in Magento refers to the general configuration of an instance. It is not the same as module configuration. General configuration defines which modules are available, the database credentials, and more. Module-specific configuration defines the behavior of a module. Framework is low-level code, not related to features and business logic. Framework defines how the whole system works. For example, interaction with databases, URL processing, logging, remote requests to tools. Modules are where Magento business logic and features are implemented. When developing with Magento, you create your own modules. Command line tool is a small but critical part of Magento 2. It is a bin Magento script that allows you to do a host of different things, like cleaning the cache, generating static content, and telling Magento to execute database upgrades. Theme is a set of files, typically static assets, that define how pages look. Parts of a theme can be located in modules, for example, functional JavaScript, or in the folder App Design. Magento U offers an entire course on how to use theming in Magento 2. Dev tools include scripts and tools that assist a Magento developer. For example, a testing framework would be located here. Generated. Generate and contain all necessary classes generated by Magento 2 via interceptor or plugin functionality. Very useful since it speeds up the system.
Magento 2 can be installed in two ways, by cloning the repository or by using a composer installation. The themes and framework will vary based on the module paths. This slide shows the different paths when using either the composer or repository methods. You can find more information about installation in the official documentation. There are many different file types used in Magento 2. This course focuses on the first 4 types presented on this slide. The last 3 apply to front-end development, which is covered in a separate Magento U course. Magento 2 configuration can be confusing to a developer who has never worked with Magento before, so all the major aspects will be covered in this course. We can divide all configuration into 3 separate groups. Global configuration, Magento instance configuration, which defines which modules are enabled, database credentials, session management, and so on. Module configuration, defines a module's behavior, which routes it supports, which events it handles, etc. Theme configuration, defines a theme's name, parent, and some other details, usually a very small amount of code.
This slide presents types of PHP classes in Magento 2. Model Resource Collection. These classes are used to interact with databases and to implement specific entity behavior, such as product or customer. Note that Magento 2 is moving away from using these classes to using API interfaces, but currently these classes are still an important part of Magento. API Interface. This is an internal module API that defines which operations are available. It includes CRUD operations for a module's entities, as well as other module-specific operations, such as customer login. Magento 2 has a special mechanism that assigns certain classes to implement an API interface. We will discuss this more in Unit 5. Controllers. Controllers are classes that handle specific pages in accordance with the controller mode in the MVC Model View Controller pattern. Blocks. Blocks are special classes that represent a part of a page. Blocks are usually, but not always, connected to HTML template files. Blocks can be thought of as a data container for a template, which represents a piece of the HTML on the page. We will talk more about blocks in Unit 3. Observers. Magento 2 fires events in different places along its execution flow. Developers can create observer classes that will react to events. Plugins. Plugins are a very powerful customization technique. Plugins can be thought of as a wrapper around any public method of any class. A developer can modify a method's behavior by using plugins. Helpers. Helpers are auxiliary classes that encapsulate some useful functions, such as performing tax calculations. Schema data patches. These scripts are special files that update a database schema or add data to a database. We will talk more about databases and scripts in Unit 4. UI components. The UI component technology in Magento 2 allows a developer to create a component, an independent element on a page with its own back-end part. We will talk more about UI components in Unit 3. Other. Note that while we have listed the most important PHP class types here, it is not a complete list.
This slide shows the typical development customization process. Your class is placed somewhere in the execution flow, where some of its methods get executed. There are many ways that this can be accomplished, including adding the class into the array of another class's constructor, creating a plugin, creating an observer. This slide provides more detail on enabling custom code. We will cover all of these later in this course. Note that this list is not complete. It provides more commonly used generic steps rather than feature-specific ways. For example, create a backend attribute for a product or a total model for a quote. Magento has a variety of ways to execute your code in different situations. In Magento 2, a module is now contained within a single folder. In Magento 2, modules have been made more granular, are better organized, and their dependencies are more explicit. This facilitates building scalable and maintainable shops. Magento 2 modules are also smaller, and the functionality is grouped in a more logical manner. For example, if you are looking for a checkout code, you only have to look in Checkout. A module provides specific product features by implementing new functionality or extending the functionality of other modules. Each module is designed to function independently, so the inclusion or exclusion of a particular module does not impact the functionality of other modules. This maximizes flexibility when customizing a site. While modules primarily define new business features or customizations to existing ones, they can also define a default user interface for those features, which are customizable by themes.
Location example. The customer module of Magento can be found at vendor Magento module-customer. Third-party modules can also be installed directly into the vendor folder from packages or private repositories by Composer. Modules under vendor make themselves known to Magento using a Composer autoload file callback, as in the code on your screen.
To name a module, follow the Magento standards on naming convention and module location within a file system. A module name consists of the vendor name and the module name separated with an underscore. Both the vendor and the module name have to start with an uppercase character. For example, Magento_customer. Code base of the custom module, root, app, code, vendor, module. Custom theme files, root, app, design, area, vendor, theme, vendor_module. Code base of custom module, root, app, code, vendor, module. Custom theme files, root, app, design, module, theme.
Magento 2 is built of modules. Its core is technically a set of modules. When a developer creates a customization, the first thing to do is to create a module. The slide describes a module. It is technically a folder located in a specific place, app code or vendor name, which has a few required elements such as the etc module.xml file and registration.php file. Modules are grouped into vendors, so typically you define a vendor folder first, for example, app code Magento U. Magento U is a vendor name here, and then a module name, for example, app code Magento U my module. My module is a module name. In Magento, modules are named vendor_module. For example, Magento_catalog. Magento equals vendor and catalog equals module, or Magento U_my module. Note that module names are case sensitive. In the following slides, we will cover the module.xml and registration.php files. The module.xml file must be located in the etc subfolder of a module, for example, Magento catalog etc. Note that the etc starts with a lowercase e, while typically a module's subfolders start with an uppercase letter. The module.xml file includes pieces of information, name, and dependencies.
This code example
Here's an example of a registration.
This code example from composer.json shows the Magento catalog inventory hard dependency on Magento catalog and other. This code example from composer.json shows.
Here's an example of a registration.php file. This file follows a typical pattern. The only thing you will change here for your module is the module name. For example, Magento U_my module. Note that the module name must match the module path, so the registration.php file and the Magento U_my module should be located either in app code Magento U my module registration.php or in the vendor folder, vendor Magento U module-my module.
The concept of dependencies, or using and being dependent upon another module's features, is important in Magento. Dependency usually means that a module is loaded after another module. You define your module in the module node and then define which modules depend on this module in the sequence node. Modules can be dependent upon the following components: other modules, PHP extensions, and libraries, either Magento Framework Library or third-party libraries. Only soft sort order dependencies on other Magento modules can be declared in module.xml. Other dependencies can be listed in a module composer.json configuration file. Best practice: you can lose historical information contained in a module if it is removed or disabled. We recommend storing such information before you remove or disable a module. Knowing the difference between hard and soft dependencies is important when you have to make configuration changes. Hard dependencies. The module cannot work if the module on which it is dependent is not installed. Examples of hard dependencies include: the module contains code that directly uses logic from another module, instances, class constants, static methods, public class properties, interfaces, and traits. The module contains strings that include class names, method names, class constants, class properties, interfaces, and traits from another module. The module deserializes an object declared in another module. The module uses or modifies the database tables used by another module. Soft dependencies. The module is able to function without the other modules on which it depends. Examples of soft dependencies include: the module directly checks another module's availability, the module extends another module's configuration, the module extends another module's layout. If your app has external dependencies, for example, you need a third-party library for a module, you will need to use Composer. A module's hard dependencies, that is, all of the components upon which the module is dependent, are listed in the module's composer.json file. The load order of any dependencies on a module is declared using the sequence element in the module.xml file. You use the sequence node to define the load order for modules. If your module depends on other Magento modules, you can include that module in the sequence so it will be loaded afterwards. The sequence element is optional and is used only when the order in which components are loaded or installed is important. Only for modules, no other component type is entered in the sequence section. This assumes that using the sequence node is a best practice.
See your course exercises guide for instructions on how to complete this exercise and the solution.
Let's look at the Magento 2 file system. This module will discuss the file system structure within Magento 2 and where critical files are located.
Here are Magento 2's 8 root folders. App includes core code, custom modules, themes, and global configuration. Bin has the Magento script, which is the Magento 2 command line tool described earlier. Dev includes different scripts and tools useful for developers. Lib includes external libraries not installed through the Composer. For the repo cloning installation, it includes the Magento framework, lib internal Magento framework. Vendor, the Composer folder, which contains all the dependencies. It may also include Magento framework and core modules for Composer-based installation. Pub, folder that should be public on the host. This folder has a static subfolder where all static files need to be placed in production. Static files can be located in themes and modules, so moving them all to pub static is not a trivial task. There is a special command available within the command line tool which allows for that. However, as it takes a while to accomplish this and is not convenient for development, there is also a static PHP file that locates and returns static files from the modules and themes. Setup, folder that contains installation-specific files. Var, an important folder where cache, logs, and other files, like uploaded CSV files, are stored.
Depicted here are the contents of an app folder. App Etsy includes global configuration, app code, custom modules, and in the case of cloning repo installation, core modules, app design, themes, app i18n, specific translation files, app bootstrap.php, app autoload.php, and app functions.php are three special PHP files that must be included at the very beginning of execution process. The slide describes where Magento 2 code is located. It can be separated to application code, main code, and framework code. Main code includes Magento 2 application logic, while framework contains general code not related to any specific feature. Magento code is mainly organized as modules. A module is a folder with a specific structure that contains code, a structural unit of code. You can perform an operation with a module, update, disable, and so on. Framework is also structured as a set of folders with code, like core, but they are just folders, not a module. This is an important point. Although framework and the main core code at first glance look similar, both a set of folders with code, they are not. Framework's folders are just folders, while main code folders are modules.
Magento code is organized in the following way. There is a folder, app code, which is where most of the PHP code is located. The code is packaged inside modules. Each module belongs to a vendor. In the native Magento installation, there is only one vendor, Magento. When you create custom code, you can create additional vendors. So, for code under app code, the folder structure is app code vendor, and inside this folder is the list of modules. PHP code installed under the vendor directory is located using the Composer autoloader, so the vendor namespace and module name folders follow the Composer convention of using all lowercase. The module then adds itself to the Composer autoloader list with its uppercase vendor and module name. For an example, please consult your participant guide.
On the slide, you can see some components of the Magento framework. Please note, framework component is technically not a module in the sense discussed above. The diagram shows possible subfolders of a module folder. Note that the only required folder is Etsy. The structure is not as strict as in Magento 1, so a module might have any subfolder. Also, a developer can place a file in any subfolder. However, the listed folders correspond to different list types, so this structure is historical and should be retained. The most popular are blocks for blocks, controller for controller actions, helper for helpers, model where models and resource models are located, setup for schema and data patches, view for layout XML files, templates, and static view files. Note that the file name must repeat the folder structure, starting from vendor module name. For example, the class of the file vendor Magento module-catalog model product.php. The capital letter folders usually have special meaning. They will be covered in more depth in the next unit, Unit 2. The View folder is distinct and will be covered extensively in Unit 3. However, we'll take a quick look at it now. To see a typical module file structure, visit the link on your screen.
This slide shows the different subfolders within the View folder for a module. Their names are self-explanatory, and we will discuss them in more detail in Unit 3.
As we mentioned, modules are located in the app code or vendor folder. All the native modules are located in the app code Magento folder. In Magento 1, templates were separated from the PHP code, making modules difficult to package. Now, in Magento 2, it is much easier. In Magento 1, all templates were located in the App Design folder and grouped by themes and packages. In Magento 2, all templates and layout XML files are located in the View folder. This makes modules more granular as all associated files are packaged within one folder. Within the View folder are directories corresponding to design areas, namely Frontend, Adminhtml, and Base. They contain folders such as Templates, Layout, and Web. The template folders contain the .phtml files, layout folders contain layout files, and the web folders contain files that are requested by the browser directly, like CSS and JavaScript. From one point of view, this is a good thing because everything is within the module directory and can be easily packaged for distribution. On the other hand, there is no longer direct access for browsers to the module web page resource files, which makes things more complicated. Magento provides a special mechanism for accessing them in developer mode, and a command line tool to copy static files into the pub folder for production mode.
Magento 2 houses all the custom design elements in one folder located in the folder App Design. Native out-of-the-box themes could be found in the Vendor Magento folder. In the subfolders Theme-Frontend-Luma, Theme-Frontend-Blank, Theme-Adminhtml-Backend. Magento 2 introduces a new concept for the platform, themes, which contain static web assets, templates, and layout files.
In this video, we will speak about static assets. So let us take a look what happens when we load any page in Magento. You see, it loads a lot of different static resources, especially CSS files, JS files. Those are most interesting for us. So two special CSS files, styles M and styles S, styles L and styles M CSS, which are very important, and many JS files. So let's take a look at some of those files and see where do they come from. We have a lot of JS files. So for example, authentication pop-up file. So we can see its path. Let's open it in a separate tab, in a new tab. Oh, yes, we open it, but it's HTML. So we have to see it in the source. So here we can see its source. It's HTML file that we downloaded. But let's now take a look at this file. So you can see that it's located in the static, some version, frontend, Magento, Luma, NUS, Magento customer template, authentication pop-up HTML. So this file, the static file, HTML file, belongs to Magento customer module. But you see this strange path. So let's locate this file. This file is located in the pub folder, in the pub static. There is no version, so a version is added automatically. And then it's in the front-end, in Magento, Luma, and NUS. And then it's Magento customer module. And in Magento customer module, we would have this authentication pop-up. Let's open also it in the terminal. Pub, static, frontend, Magento, Luma, NUS, Magento customer, templates, and here we go. We see this authentication pop-up being a symlink to a physical file, which is located in our document root. So this is how Magento operates with static assets in developer mode. So we can remove it, authentication pop-up. And let's try to hit it again. We can hit it again. And we got it again. Now, if you take a look here, we will see this file generated again. So how does it work? Let's remove it once again. The tricky thing is that Magento will redirect every static content that comes from pub_static folder it will generate it on fly. So every request will, if the resource does not exist, every request would be redirected to static.php file. Let's test it. Let's say exit hi there, just to check. Now we go to our resource and let's refresh our file. So hi there. If this HTML file does not exist, this request would be redirected to static.php, and static.php will locate the requested file in the module folder and generate a symlink. And this mechanism only works for Magento in the developer and default mode. In production mode, Magento will not generate static files, and you have to generate it with a special command and deploy them all into this folder. This will work much faster, but it generates huge inconveniences in development.
When should static files be placed in a theme rather than in a specific module? Select your answer or answers and then click Submit. This module will discuss the important procedures used during the development process in Magento 2, modes, command line tools, and caching.
Magento 2 can run in one of three primary modes: developer, production, and default. One of the biggest differences between the modes is how static view files get served. Static view files are CSS files, JavaScript, and images from modules that have to be processed before they can be delivered to a browser. There is also a maintenance mode, but that operates in a different way, only to prevent access to the system. You should use the developer mode while you are developing customizations or extensions. The main benefit to this mode is that error messages are visible to you. It should not be used in production because of its impact on performance. In developer mode, static view files are generated every time they are requested. They are written to the pub_static directory, but this cache is not used. This has a big performance impact, but any changes a developer makes to view files are immediately visible. Uncaught exceptions are displayed in the browser rather than being logged. An exception is thrown whenever an event subscriber cannot be invoked. System logging in var report is highly detailed in this mode. You should run Magento in production mode once it is deployed to a production server. Production mode provides the highest performance in Magento 2. The most important aspect of this mode is that errors are logged to the file system and are never displayed to the user. In this mode, static view files are not created on the fly when they are requested. Instead, they have to be deployed to the pub static directory using the command line tool. The generated pages will contain direct links to the deployed page resources. Any changes to view files require running the deploy tool again. Because the view files are deployed using the command line tool, the web user does not need to have write access. The Magento pub static directory can have read-only permissions, which is a more secure setup on a publicly accessible server. As its name implies, default mode is how the Magento software operates if no other mode is specified. In this mode, errors are logged to files in var reports and are never shown to a user. Static view files are materialized on the fly and then cached. In contrast to developer mode, view file changes are not visible until the generated static view files are cleared. Default mode is not optimized for a production environment, primarily because of the adverse performance impact of static files being materialized on the fly, rather than generating and deploying them beforehand. In other words, creating static files on the fly and caching them has a greater performance impact than generating them using the static file creation command line tool. Here is a summary of the key features that distinguish each mode. Maintenance mode is used when you want to make the site unavailable to the public during updates or other changes. Maintenance mode works differently from other modes. You don't use the mage mode variable. Instead, you use the file var.maintenance.flag with the mode set to default. The method bootstrap assert maintenance controls this mode. When maintenance mode is enabled, the screen will show the error message 503 internal server error. You can specify a group of people to have access to the site while this mode is employed by placing the associated IPs as a comma-separated list without whitespace in the file var.maintenance.ip.
Using environment variables allows you to set the mode for your Linux, Windows, Apple, or any other system. However, this approach has disadvantages. The process to set an environment variable differs depending on the web stack being used. The other approach to setting mode is to set environment variables in the web server. The most popular web server setup is probably Apache with mod.php. Environment variables can be set in the main Apache configuration or in htaccess and pub htaccess files. If you're running this type of stack, the easiest way to set a desired run mode is using the setenv configuration option as shown on the slide.
For instructions on specifying the mode using the PHP FPM system environment, please consult your operating system documentation. On Unix systems, the environment variable can also be set by exporting it into a shell before restarting the service. Export space mage_mode equals developer.
In this video, we will speak about Magento modes. When we install Magento, we are in the default mode. There are three modes in Magento: default mode, developer mode, and production mode. When we do our development, we always use developer mode. The mode that Magento is in defines multiple things. It will affect performance. It will affect the way how Magento generates static content. It will also affect error reporting. In the production mode, we will not be able to see errors. In the default mode, we would see errors right on the screen. So let's see how we can set a mode. Basically, mode could be set in multiple ways. It could be done through the environmental variable, for example, in the htaccess file. You see that set env mage mode. developer. If you uncomment this line, this will set your mode to developer if you use Apache. You have to do it in two places, in the htaccess and also in the pub htaccess. So in those two htaccess files. We are not using Apache here, we're using Nginx. So we can set an environmental variable in the Nginx config, which is not very convenient. Fortunately, there are two console commands in Magento that we can use in order to see what is the current mode and in order to set the mode. Those commands are php bin Magento. Let's take a look into them. List. So there are two commands, deploy mode set and deploy mode show. So let's say php bin Magento deploy mode set show. We are in the default mode. We can also see and modify the mode in a special file in the app etc env.php file. Env.php file has a general configuration of our system, and so it has configuration of the mode. You can see we have mage mode default. We can change this file and change this to production or developer. But usually what we do is that we set mode using command. So we do that php bin Magento deploy mode set developer mode. Okay, so php bin Magento deploy mode show. Wait a little bit, and we are in the developer mode. In developer mode, static files would be symlinked, and it will be very easy to modify them. In developer mode, we will see all errors, and in developer mode, Magento will not cache classes definitions, which allows us easier develop and debug while we're doing our development. So when we develop, we always use developer mode. Let's also take a look into the env.php, and we see that env.php has changed. So
see your course exercises guide for instructions on how to complete this exercise and the solution. Magento has one command line interface based on Symfony that performs both installation and configuration tasks. Your Magento install directory /bin/Magento. The new interface performs multiple tasks, including install Magento, clear cache, manage indexes, generate non-existent classes, factories, interceptors for plugins, DI configuration for the object manager, deploy static view files, clear static files to comply with static file fallback rules. Review the notes to see the command that will enable and disable available modules. To list all available installation and configuration commands, use the command php your Magento install directory /bin/Magento list. Note that the CLI is extensible, allowing for easier integration with third-party applications.
Caching in Magento 2 is extending the Zend cache component. In Magento 2, you use the Magento Cache Library component. Magento 2 sets a default caching configuration with installation. It is unlikely you will want to change these settings. But if you do want to create a custom mechanism, the basic default list of cache types is located in app etc env.php. In Magento 2, there are many different cache types. For example, configuration, layout XML, HTML block output caches, class definition, and so on.
In Magento 1, there are different cache types like configuration, layout XML, HTML block output caches, and so on. In Magento 2, there are even more cache types. For example, the class definition configuration. There are 3 options for cleaning: using the admin interface functionality, the bin/Magento command line tool, or manual removal. It is preferable to clean the cache via the backend or the command line tool because these processes thoroughly clean the cache, even if a non-default cache storage is configured.
See your course exercises guide for instructions on how to complete this exercise and the solution. Within this
We will now
module,
discuss
we
the
will
important
address a
topic
number
of
of key
dependency
topics:
injection and its
dependency
relation to
injection,
Magento's Object Manager.
objects, and Object Manager.
Dependency injection is a way to retrieve objects. In this process, classes receive objects they depend on as constructor arguments. In Magento 2, the Object Manager is responsible for creating all objects a class requires. You define your class with the constructor receiving the argument objects that it needs. The dependency injection system, basically the Object Manager, will create them for you. All this is based on configuration. Dependency injection is a complex topic which may be new to you. Do not worry if you do not immediately absorb all of the concepts presented in this module. We will use dependency injection throughout the course in many of your exercises, and each time you work with the concept, you will build your knowledge and confidence.
Dependency injection is configuration that is XML-based and validated by XSD. Magento 2 uses dependency injection as a class instantiation mechanism. Assume you need a store manager instance in your product class. You can declare an argument with the type store manager interface in the constructor of the product. Now, using di.xml, you have to define which class will be substituted for that interface. For that, you have 2 options. Define a preference and it will work globally, which means that every other class that declares an argument with the type store manager interface will receive what you defined as the preference. Assign a class in your di.xml for this particular object, product, and the preference will not be global, but only apply to product.
See your course exercises guide for instructions on how to complete this exercise and the solution. This diagram shows how classes are typically instantiated in Magento. The constructor original class is key. It contains a list of declarations, dependencies, that could be other classes, interfaces, factories, and others. When the original class is instantiated somewhere in the request processing flow, the DI mechanism reads its constructor and instantiates dependencies based on the configuration in the merged di.xml file. This is a very powerful construction. A developer can declare a di.xml and change something in another module, for example, adding an element to an array in the constructor of another class.
Of course, the best candidate to use with DI is a singleton-type class. By singleton-type class, we mean a system class that usually exists in a single instance and is used in different places in the code. Examples could be cache, session, registry, helpers, and other classes. Note that factory or API class also matches this definition. It is important to understand that not every class has to be injected using dependency injection. For example, so-called entity classes like product. Which product to use really depends on the data in the database. For these classes, it is recommended to use factories for injecting. For example, if you want to instantiate and then load the Magento Catalog Model Product class, you would include a factory in the constructor, create a product instance using the factory, and then load it, as shown on your screen. This example demonstrates a best practice for Magento to use API interfaces for CRUD operations. We will discuss these more in Unit 5. Another important note: the factory class may not exist. When the DI mechanism identifies a class ending with factory among the parameters, and this class does not exist, it will generate such a class in the generation folder. For example, it would be generation, Magento, catalog, model, productfactory.php with the create method.
Now let's talk about how Magento 2 instantiates objects. This involves the discussion of object management, dependency injection, and plugins, as they are all a part of the same system. This is the biggest change in Magento 2 and resolves some of the issues encountered with instantiation of parameters. The new approach makes it much easier to make customizations. In Magento 2, the Object Manager has replaced the Mage class. The Object Manager is the class that creates all objects and is responsible for instantiation. Generally, the creation of an object is one of the biggest problems in software development. In Magento 2, the Object Manager has two methods, get and create. The get method will return a singleton object, called a shared instance in Magento 2, from the protected registry, while the create method will create a new instance of the given class. Generally, it is best practice to avoid calling the Object Manager directly. Instead, you should create objects in another way. We will look at this a little later in the unit. The Object Manager is concerned with the arguments that are passed in as a class constructor's parameters. It parses the parameter types and parameter variable names. It uses configuration to resolve which arguments should be used for a given parameter. It creates the required arguments recursively. If you declare your instances to be shared, then it means they will act as singletons. Shared instances can still be modified, but it becomes more difficult with Magento 2. To see examples of get and create methods, please consult your participant guide.
The slide shows an example of direct usage of the Object Manager class. An Object Manager instance allows you to create any other class. For example, Object Manager Get, Magento Catalog API Product Repository Interface will return the same implementation of Product Repository Interface as you would receive by including it in the constructor. Note that using Object Manager in your code breaks the DI concept. That is why it is not recommended. As discussed earlier, some classes in Magento are auto-generated. Here are some other examples. Interceptor is a class that allows the plugin functionality to work. When you require a class in your constructor and Magento sees it has a registered plugin, Magento will then generate an interceptor with the same methods as the required class, but will call a plugin in that method. Search for interceptors in the Generated folder and take a look at their structure. Note that they are all pretty similar. Interceptors use PHP traits to extend both the abstract interceptor class and the original class. Proxy is a tool that helps with circular dependencies and relates to an internal implementation of how DI works, so you won't have to deal with them directly.
Magento 2 provides a new approach to working with objects. It not only encourages you to use the Object Manager, but also creates an object for you. Now you need to use the real class name, including PHP namespace, when you require an instance of a class. The creation of objects is such an important process that Magento 2 handles it automatically via the Object Manager and class dependencies declared as constructor parameters. The Object Manager creates the objects you need injected into your classes. It will recursively also create any arguments for the objects your object requires. When a developer declares an interface in the constructor, the Object Manager will automatically create the matching implementation for it, so you don't have to use it directly. So, when you create a class and you require an instance of an interface in this class as a parameter for the constructor, that interface is the only dependency your class will have. You may not know what object you are getting for an interface, but if your class is programmed only using the interface, it does not need to know a class definition. Magento 2 uses preferences to define what class will implement the interface. This is a very modern approach for the PHP community, thinking in terms of interfaces and not implementations. You can create a customization that will make Magento use your implementation of an interface and not the native classes. To view the interface preferences for the Object Manager, use the files listed on your screen. To define your own preferences, you will need to define your own DI.xml, your module directory, etc DI.xml, your module directory, etc area name, DI.xml. See your notes area or scroll on your screen for a constructor method signature example.
Magento always uses only one di.xml configuration during any given request. It includes the merged result of the app etc di.xml, each module's etc di.xml file, and the area-specific di.xml files from every module where the area matches the current request area, for example, front-end or admin.html. You can not only define preferences for interfaces, but also for regular classes. Preferences define which classes will be instantiated for a constructor argument of your class. For example, public, function, construct, Magento, catalog, API, data, product interface, product. If you require this interface in your code, you will get an instance of the class Magento, catalog, model, product because of the configuration displayed on this slide. This configuration is located in the Magento, catalog, Etsy, di.xml. The global di.xml, app Etsy di.xml, defines preferences for key Magento classes. In Magento 2, it is a best practice to request only interfaces and not concrete classes. For example, in your code, you would request the Magento, framework, app, response, HTTP interface instead of the concrete implementation Magento, framework, app, response, HTTP. The global file di.xml contains preferences for key interfaces. There are different types of arguments. In this example, you can see several types: string, array, and object. Di allows you to define which object should be used as an argument when a new instance is created. So, we have a system where something is required, for example an object or interface, in the parameters, without calling the object manager, and Magento delivers the object that implements that interface. In some cases, the object manager will not be able to deliver exactly the required object. For example, when you need a specific product with specific data, the class dependency can only require a generic product object. It can't provide a loaded entity. As a result, this type of object is not injectable. There is no hard distinction between injectables and non-injectables. The question is, how can I require a specific entity? The system allows you to get the objects you want, but for some objects, it does not make sense to have them generated by dependency injection. You will have to get those by the object manager, then load them, and so on. This will be discussed more in the unit about repositories.
A shared object is an analog of a singleton. You may encounter situations where you want to use the same instance of a class within several other classes. In the example on the slide, the instance of Magento Framework Indexer Interface that is injected into Magento Catalog Model Indexer Product Price Processor will not be shared. The argument shared on the argument node is set to false. If it is set to true, the same instance would be injected every time the price processor is instantiated. It is possible to use the shared argument on both types of nodes and argument nodes with the XSI type set to object.
In this video, we will discuss dependency injection. We will explore one of the core modules, for example. So we will take a look into the catalog module. So when we speak about dependency injection, there are few things that we need to know about. There are preference, virtual type, and argument. So let's start with preference. Preference is a declaration in the XML file which allows to identify what class would correspond to certain interface. So here we can see an example for Magento Catalog API Data Product interface. Magento will select its implementation, which is Magento Catalog Module Product. This implementation has to implement this interface, otherwise we will face an error. Let's take a look into that interface and its implementation. An interface is in the API data product interface. Here we go. So here we have some interface. It's really an interface. It has no implementation in it. Now we shall take a look into the implementation, which is Magento Catalog Model Product. Let's take a look. Catalog Model Product. Here we go. So Catalog Model Product here's the definition. It implements our product interface. So it implements all that methods. So now, anywhere in the code, we may require in our constructor, the interface, and we will receive the preference, which is defined in the XML file. For example, here in the same product model, we require interface of Magento Catalog API Product Attribute Repository Interface. You can go back to the XML and search for Product Attribute Repository Interface. So now we can figure out which physical class corresponds to this interface, which means anytime when Magento will instantiate instance of a product, it will set instance of that class, as a parameter to a product model which corresponds to this interface. Second thing that we wanted to have to know about is virtual class, virtual type. Virtual type is a string or a class which does not exist. Why would we use a virtual type? We can use virtual type in a situation when we want to use certain class with a certain configuration. So for example, in this example we can see here, we have a virtual type which is called Magento Catalog Module Session Storage, which will be an instance of Magento Framework Session Storage with the parameter namespace equal to catalog. So Magento will instantiate instance of the storage and set its parameter to catalog. And this object will be placed whenever you require in your constructor instance of Magento Catalog Model Session Storage. So virtual type allows us to configure special classes and give them other names that we can use in our classes, in our constructors of our classes. This is very powerful and useful technique. The next customization, the next ability and ability to customize and the power of the eye that we're going to discuss is argument. So let's take a look into argument. Argument can be property of regular type or a virtual type. So argument defines actually what would be passed as a object argument in constructor. Let's take a look here. For example, we have Magento Catalog Helper Data class. Let's take a look into that class. So we have helper data class. Let's take a look into its constructor. It's a huge constructor, and we can see it has parameter called template filter model. Now this template filter model will have a type of string, and this string would be this text. There is another parameter called catalog session. Let's take a look into that. Where is catalog session? Here we have catalog session parameter, which is instance of a Magento catalog model session object. And we can see that in this case it would get some other object instead. So using this argument tool, we can specify what exact parameter will be passed into the constructor arguments when object is instantiated. This is another very powerful technique. So in your code, you may change any object of any class with your custom implementation if you need to do so. And Magento follows dependency injection concept, which means that all classes that Magento use would come through its constructor. So it gives you huge power in customized Magento. And the last thing, which is also very important, is one particular case of arguments, which is array. So for some classes, they would have array argument or argument of type array. And for such arguments, we can add items to that array. For example, we have a class Magento catalog, model, entity, product, attribute, design, options, container. Let's take a look into that class. Model, entity. Here we go, model, entity, attribute, design, options, container. Here we have a class. This class extends another class, which is EAV config, Magento EAV model source config. Let's take a look into that class. Here's Magento EAV model entity config, model entity attribute source config.php. So this class has a constructor of array of options, and so container class, which extends it, will also have a constructor with array of options. And now we can set items into that array, and we can do it from any module. So in your module, you can create the same declaration in your DI.XML. Those DI.XML would merge, and finally, this object would receive multiple elements in its option array. This is very common technique and very powerful technique, so it's used a lot in Magento, and it's very, very useful for customizations. Those three concepts of DI.XML, preference, virtual type, and arguments, are key of Magento dependency injection system, and it gives extreme flexibility and power for developers to create customizations. There are also another set of customizations that could be done with plugins, which we did not cover in this video, but it would be covered in another video.
See your course exercises guide for instructions on how to complete this exercise and the solution. How does Magento define which instance of an interface should be delivered? When you check the file system, you notice there are almost no factory classes. So what then is delivered? You look at the filter pool class and notice it uses array elements and parameters, but it was created as a regular class by being included in other class controllers. So, how does Magento define what should be in the array?
This module discusses how best to use one of the powerful new features within Magento 2, plugins. Plugins together with DI change the developer experience. The purpose is to make customizing Magento simpler and to decrease the probability of conflicts between extensions. Plugins are used to extend, change, the behavior of any native public method within a Magento class. Native methods refer to those Magento class methods included with a native installation. The behavior of native methods can be changed by creating an extension. Extensions use plugin classes to change the behavior of the target methods. Plugins change the behavior of the original class, but not the class itself. You cannot use plugins for final methods, final classes, private methods, or classes created without dependency injection. To ensure that plugins work correctly, you must follow declaration and naming rules. Note: plugins allow you to modify a single method, while a preference allows you to change a whole class. In other frameworks, interception is known as AOP, Aspect-Oriented Programming.
In Magento 2, customizations can be accomplished through events and plugins. Events are the implementation of a well-known development pattern, Event Observer. Events are covered in detail in the next module. Plugins allow you to customize a single method. This process is basically rewrites and events on a method level. Plugins offer the ability to create methods that execute before a target method, to modify the arguments passed to the target method. A plugin can also execute after the target method in order to modify the returned result. A plugin can be called before, after, or even instead of the target method. Plugins do not conflict with each other because they are executed sequentially.
You must specify the following elements when declaring a plugin. Type name, a class, interface, or virtual type that the plugin observes. Plugin name, an arbitrary name that identifies the plugin, used to merge the configurations for the plugin. Plugin type, the name of a plugin class or its virtual type, uses the naming convention model name plugin. The following arguments are optional and should only be specified if needed. It is a best practice to omit these arguments by default. Plugin sort order, the order in which plugins that call the same method are run. Plugin disabled, set to true to disable a plugin. Here is an example of a plugin. The syntax is very simple. The way it works: you define a plugin, you create a class within another class, then inside that class you can define which methods write the plugin. If you need to change the arguments of an original method or add some behavior before the method is called, you should use the beforeListener method. A code example is presented on the slide.
If you need to change the values returned by an original method or add some behavior after an original method is called, you should use the afterListener method. A code example is presented on the slide. Please note that after plugin has access to the arguments as well as before. Magento passes arguments after the result parameter, such that each argument will be represented by its parameter. Also note the example of accessing the username argument of the original login method.
If you need to change both the arguments and return values of an original method, or add some behavior before or after the method is called, you should use the aroundListener method. The aroundListener method will receive two parameters, subject and proceed, followed by the arguments belonging to an original method. The subject parameter will provide access to all public methods of the original class. The proceed parameter is a lambda that will call the next plugin or method. Any further method arguments will be passed to the aroundPlugin methods after the subject and the proceed arguments. They have to be passed on to the next plugin method when calling proceed. A code example is presented on the slide. Use one or more of the following methods to extend, modify an original method's behavior with the interception functionality. Change the arguments of an original method through the before listener. Change the values returned by an original method through the after listener. Change both the arguments and returned values of an original method through the around listener. Override an original method, a conflicting change. Note: overriding a class is a conflicting change, meaning other extensions that declare a plugin for the same method might cease to function. Extending a class's behavior is a non-conflicting change. If several plugins apply to the same original method, the following sequence is observed. The before listener in a plugin with the highest priority, that is, with the smallest value of the sort order argument. The around listener in a plugin with the highest priority, that is, with the smallest value of the sort order argument. Other before listeners in plugins according to the sort order specified for them, that is, from the smallest to the greatest value. Other around listeners in plugins according to the sort order specified for them, that is, from the smallest to the greatest value. The after listener in a plugin with the lowest priority, that is, with the greatest value of sort order argument. Other after listeners in plugins in the reverse sort order specified for them, that is, from the greatest to the smallest value. Inheritance affects the order of the plugin loading. Each Magento 2 module has its own set of configuration files gathered into the module's etc directory. Depending on the needs of your module, you might have the following configuration files: acl.xml, config.xml, di.xml, module.xml, webapi.xml. Because of configuration inheritance, we can create a module, make it dependent from a core module using the sequence node in the module.xml and composer.json files, and redefine a preference for a certain interface using the di.xml. In this case, our preference will be taken into account, which will have a similar effect as a rewrite in Magento 1. Configuration files from modules loaded later can change values declared by configuration files loaded earlier. This is why specifying the sequence is important. Configuration inheritance involves some expensive operations in runtime. The compiler tool can be used to minimize the performance impact of these operations.
Interception provides the ability to observe public method calls in an application, and is therefore used to reduce conflicts among extensions that change the behavior of the same class or method. Plugins can be created for any object in an application created through Object Manager. These plugins will observe method calls for that object and allow for adding behavior to these observed methods. Multiple extensions can add plugins to the same object independently without causing conflicts. These plugins are called sequentially based on configured sort order.
In this video, we will talk about plugins in Magento. So plugin is a customization technique which is also used a lot in Magento core, which allows a developer to add some code before, after, or instead of certain public method of the class. If the class is created via Object Manager, which is usually the case, we can customize it using plugin. In order to customize the class, we have to declare a plugin in the .xml file, and the example of declaration you can see here in the catalog module. So we should specify a type node, specify name of the class, and then specify plugin and type of a plugin. And type of the plugin is a class, plugin class. There are 3 plugins possible: before, around, and after. Let's take a look into them. Around plugin is probably the most complex one. Around plugin looks like around and method. So the original class, customer group, would have save method, and we create a plugin by adding around to that. We will have parameter of the method and the result of the method, but we will also get a closure proceed. We may execute this proceed, which will execute original method. So we can do something before method, we can execute it and do something after the method. We may select not execute it at all and do something else instead. Other example is after plugin. After plugin would get original object and then its result and parameters of the object. It will be executed after the original method. So again, the original class would have public function get, and in order to pluginize it, we would create public function after get method, which would get first parameter would be original object, second parameter would be result, and the rest of parameters would be parameters of the original get method. So we can do something in the after plugin, and then we can return something. And whatever we return will be a return value of the original method. If we return nothing, original method will return null. This is a very important point and mistake of Magento beginners. Before plugin allows us to access original object and parameters and do something with those parameters. Plugins do not have to extend any class. So this is just a regular PHP class which would have before, after, or around methods.
This exercise is optional. See your course exercise guide for steps on how to complete this exercise and the solution.
See your course exercises guide for instructions on how to complete this exercise and the solution. Look at the file constructors in your Magento installation at Magento Framework View Layout, Magento Framework View Element, UI Component, Data Provider, Filter Pool. Note the following types of parameters there: classes, interfaces, factories, arrays, variables. Examining these constructors should raise some questions for you. See if you can answer any of the 3 questions on the next slide.
How does Magento define which instance of an interface should be delivered? When you check the file system, you notice there are almost no factory classes. So what, then, is delivered? You look at the filter pool class and notice it uses array elements in parameters. But it was created as a regular class by being included in other class controllers. So how does Magento define what should be in the array? These questions will be answered in the content that follows.
This module focuses on events and related topics. Events are commonly used in applications to handle external actions or input, such as a user clicking a mouse. Each action is interpreted as an event. Events are part of the event observer pattern. This design pattern is characterized by objects, subjects, and their list of dependents, observers. Events trigger objects to notify their observers of any state changes, usually by calling one of their methods. It is a very common programming concept that works well to decouple the observed code from the observers. The code fires an event, and the event manager checks whether there are any observers registered. Events can be global or registered only for a specific area, such as front-end or Adminhtml. Events are declared in an events.xml file. If there is an observer registered, the event manager will call this observer method and pass the event's parameters to the observer. So, an observer has access to an event's parameters. If there are no observers registered, then the event has no effect.
This example is taken directly from the Magento code. First, you can see how an event is fired in the code. Note its parameters, order, and quote objects. Next, you can see how an observer is declared in events.xml. Continued on the next slide. And finally, an observer instance. It must implement the execute event observer method. The observer object has an event object available through observer getEvent, which contains the event's parameters, quote and order in our example.
In this video, we will talk about events. First of all, some core file, usually it's core file, can fire an event, and it looks like this line 416. This event manager dispatch. So in many places in the core code of Magento, there are calls like that, event manager dispatch. Then inside of a dispatch method, there will be two parameters. One is a name of the event, and second is an array of parameters. So here on this example, we can see two events, customer login and customer data object login. Each event would have its own array of parameters. In both cases, there's only one parameter, customer, which is customer object, and again customer, which is customer data object. Now, if we want to, we can create our customization, and we can register an event register an observer for this event or for any other event fired somewhere in Magento. Magento core files can also register an observer for event fired in another place in the core. We can take a look into example of an events.xml file from module catalog in the front-end area. So there are two observers, one for customer login and one for customer logout. In order to register an observer, we have to create events.xml file, either in the etc folder or in the specific area folder. Could be frontend, Adminhtml, cron, or web API REST or web API SOAP. Inside of event.xml, we have to create an XML like that. So it starts with config, then it's event node, which defines an observer itself. It will have attribute name, then event name, node observer, name of the observer, which could be anything, an instance, a string that contains class name that would be an observer. Shared false, as usually means that this object should not be shared and should be created every time for every observer if we use same observer for two different events, which is unlikely. Now let's take a look into observer itself. Observer class has to implement observer interface. It's Magento framework event observer interface, and it has to implement method execute. As a parameter of an execute method, observer will receive an object of Magento framework event observer, which contains data passed into the event. Here we can see data is array, and in our case it only has one value customer. We can take a look into another observer where data is used. So this is typically how we get access to the data. We go observer, get event, get quote. So this will get us access to the quote object, quote parameter of the event. In this case, if you would like to get an access to the customer object, we can do something like that. We would say customer, observer, get event, get customer. So this will give us access to this object that is passed to the event. Events is a powerful customization technique in Magento 2. It used a lot in the core code, and it's also used a lot in customizations.
See your course exercises guide for instructions on how to complete this exercise and the solution.
We now move on to discuss Magento 2 configuration. Now, files are split by function and meaning, so you are left with a bigger number of XML files. Each type of config file has one specific purpose and syntax. For example, each module has a module.xml for module declaration, a config.xml for default settings of system configuration fields, an event.xml for events, and so on. These XML files tend to be rather small, and each file follows a very strict syntax that is validated using an XSD. This is helpful for developers because modern IDEs often offer auto-completion.
Within this section, we will discuss these key topics: module configuration files, error reporting settings.
Magento is a highly configurable system. Many different configuration files and configuration options exist in Magento. Overall configuration can be broken into three major groups. Application configuration includes configuration files which defines Magento instance settings, such as database connection, cache configuration, Magento mode, and so on. Modules configuration is represented by a set of configuration files in each module's etc folder. There are tens of possible configuration files allowed there. We will cover many of them during this course. Magento has core modules and custom modules, and both have their own configuration files. System configuration is a configuration that is available for a merchant. It is saved in the database and rendered in the admin panel. Application configuration is located in the app etc folder. There are multiple config files there. The most interesting for us are the following. env.php contains information about connection to the database, cache configuration, Magento mode, and so on. config.php is an auto-generated file containing a list of modules with the flags that indicate whether the module is enabled or not. di.xml contains general di configuration which is not specific to any module. We will talk about di later in the course. db_schema.xml has an instruction to create a patch_list table which is used to process data and schema patches. Modules configuration is located in the etc folder. Config files except module.xml could be in etc area folder. Area could be front-end, Adminhtml, cron, web API_REST, web API_SOAP. If a config file is located in etc area folder, it will only take effect for this folder. Each module may have different config files. The general ones, introduced by the framework, are di.xml, db_schema.xml, module.xml, events.xml, acl.xml, menu.xml, and system.xml. We will cover different config files in the corresponding sections. In Magento configuration, XML files are merging. It means that if multiple modules declare the same config file, the system will see the merged result. This is applicable to all modules' XML configuration files. It is possible to define the rule of merging configuration files.
In Magento 2, there are two main ways to store configuration values: in a database for merchants and in XML files for developers. Storing the configuration in a database in the table core config data allows a merchant to be able to change it through a generic interface. Therefore, database-level configuration options are usually ones that a merchant can understand and change using the backend interface. XML file-level configuration options are usually more technical and should be changed by a developer. The names of XML files generally make their function obvious, such as widget.xml, events.xml, and routes.xml. Magento 2 has added some important new XML files, most notably the module.xml and the di.xml. This diagram displays the core config data table structure, which stores the configuration data a merchant specifies using the admin interface. Core config data includes scope and scope ID fields. Scope can be global, website, or store. If scope is set to website, the scope ID is treated as website ID. If scope is set to store, it is a store ID. For global scope settings, it does not apply. Here is a picture of the backend admin system configuration settings interface. For Magento 2 XML configuration files, there are three scopes: global, front-end, and admin. Some configuration options are scopable, others not. For example, an event can be either global or front-end or admin, whereas the module.xml file can only be in the global scope. If a configuration file is placed directly within the etc directory of a module, its values are applied in the global scope. To specify front-end or Adminhtml scope values, the configuration file needs to be placed in the folders etc frontend or etc adminhtml respectively. Each scope corresponded to a different branch of XML within a single configuration file. The system will load only the configuration data that is needed. For front-end requests, it will not load values from the admin.html folder and vice versa. If you need to specify values for both admin.html and front-end, a global scope file can be used. If the same configuration file is present in both the global scope and the request scope directories, they will be loaded and merged together. Note that some configuration options work only on the back-end, admin, some on the front-end, front-end, and some on both, global. Let's now discuss the merging of configuration files. In Magento, nodes are merged based on their XPaths and then identifier attributes. The assigned identifier must be unique for all nodes nested under the same parent node. Otherwise, an error occurs. Magento 2 uses schemas to make validation of configuration files faster and easier. In Magento 2, in addition to every .xml file, there is an XSD file that helps validate against a schema. The most important .xsd files are located under lib, internal, Magento framework, and other directory branches. Example: events are declared within the events.xml file, and then the configuration type is validated in the events.xsd file. The events.xsd file is located at lib, internal, Magento, framework, event, etc, events.xsd.
Each XML file in Magento usually has its own XSD schema. XSD schema is specified in the schema location attribute of config node of any XML file. Pretty much applicable to any file. So we can see for events XML, The schema is located in the framework event etc events XSD. In the DI.XML, schema would be again in Magento framework object manager etc config XSD. So pretty much every XML file in Magento, configuration XML file, would have its XSD schema, which is used for validation of the correct syntax of this file. We can also use XSD schema to better understand syntax of the file and all configuration nodes that are allowed for this file. For example, let's take a look into the schema of the events.xml. This is a file in Magento framework etc event etc events XSD. So here you can see what's allowed inside of the events XML. It should start with config. It should have event node. It should have observer with the name, and you can see how it will be validated and what's allowed or not. So even if you create a new XML, custom XML file, we still will create a validation XSD. But all Magento core XML files created by Magento, they all definitely have XSD schema. We can refer to the schema to understand the syntax of the file, and also the schema is used for automatic validation of XML configuration files in Magento.
Magento 2 uses the highest level of error reporting so that even a PHP notice will cause an exception. Note that the way errors are displayed is determined by the mode. In developer mode, errors will be returned as a stack trace, allowing you to see the exception path and refine your code. In other modes, there will only be a message that an error has occurred, but the error itself will be recorded into a log file. Check your understanding. If instead you wanted to extend an existing configuration type in your module, which of these three things would you definitely have to create? The .xml config file, a loader, the .xsd schema.
See your course exercises guide for instructions on how to complete this exercise and the solution.
Congratulations! You have completed Unit 1. You can review the material in this unit or advance to the next course unit, Unit 2.